All right, so today we are going to be talking all about geometry today. Today is just one topic, and that is geometry. Now, I know geometry sounds pretty scary. Some of you loved it, some of you hated it, but we gotta talk about it. So, don't worry, it's a lot of really just easy concepts that you have to remember. There aren't any really tricky formulas or anything. Just really short and simple formulas, and yeah, not a lot of math, I don't think. So geometry is a type of math that mostly deals with points, shapes, surfaces, lines, and angles. So we're going to start with lines and angles first. And I think a good place to start is talking about the line segment. So there's also going to be a lot of vocab I'm going to be throwing at you guys. So again, feel free, if I'm going too fast, just stop me, ask questions, all that good stuff. Okay, so first we're going to talk about line segments. And so a line segment is basically just a piece of a line that has an exact measurable length. And so I'll show you a little example, something like this. This is a line segment, and line segments can have multiple parts to them, so maybe something like this. And typically they're labeled with letters, so like this is point A, then you got point B, point C. So this is a line segment. It's just a piece of a line where you can measure the lengths. So, for example, you might see something like this on the ASVAB where it's like, let's say AB has a length of, I don't know, 7. And let's say that the total line segment, or AC, has a total length of 12. Find the length of BC. So if this segment is 12, and the whole segment is, sorry, I got that mixed up. If AB is 7, and AC, the whole thing is 12, then the length of the smaller one is going to be 5. Right? Because this is 7, this would be 5, and the whole thing is 12. Does that make sense? Okay. And sometimes you'll see something like this where you have a line segment, right? Let's call it A, B, and C again. And B is like perfectly in the middle of the segment. Obviously, this is just a drawing, so my drawing's not perfect, but you might see a question where B or a point is directly in the middle of the line segment. This is called a midpoint. And what a midpoint does is it bisects a line segment into 2 halves. And so whenever you see a line segment with a midpoint, these 2 parts are going to be the same length because B is directly in the middle. So let's go with our 12 example again. So if the total length is 12, each of these segments are going to have a length of 6, right? Because 6 is half of 12, so 6. AB is 6, BC is 6, the whole line segment is 12. Everyone got that? Can I erase? Awesome. All right, we're going to talk about angles now. There are all kinds of angles in geometry. Let's start with the right angle. So a right angle it literally just looks like an L. It's L-shaped, and typically it's marked with a little box here. So anytime you see an angle like this with a little box in it, that means it's a right angle. And the key thing about a right angle is that it is 90 degrees. It is measured 90 degrees. anytime you see lines that intersect and make a right angle, those lines are called perpendicular lines. Perpendicular lines. So for example, if I was to make these lines a bit longer, right? These lines, they intersect or they cross into each other. They make a right angle. So these two lines would be perpendicular. So that's a right angle, 90 degrees. Now we have acute angles and obtuse angles. So an acute angle is an angle that is less than 90 degrees. So it looks sometimes like this, like this, like that. These are horrible drawings, but the key thing with an acute angle is that it is 89 degrees or less. That's right, even if it's 89 degrees, that still counts as acute because it's not quite 90. So any angle that is 89 degrees or lower is considered acute. And then obtuse is the opposite. It looks something like that, right? So it's the opposite of acute. It is any angle that is greater than 90 degrees. So 91 degrees or greater. So these are the three major types of angles. All right, you guys got all that? Okay. Here are some other key things about angles that you're going to want to remember for the SBAT. Whenever you see angles that form a straight line, so for like this, for example. So you see how this is a straight line, right? And you have a line going this way, and you have two angles here, right? You have this one, you have this one. You have two angles formed here. Anytime you see two angles that form a straight line, this is called supplementary angles. And the key thing about supplementary angles is that they always add up to 180 degrees. That's the main thing with the supplementary angles. So let's say this one here measures 80 degrees. This one here measures 100. And then anytime you see angles that meet up at a point or around a point, so let's say like this, for example. Right, so see how I drew an X, but you have 4 angles here, right? And they all meet at this middle point. Angles that meet up at a point add up to 360 degrees. See how that kind of looks like a circle in the middle? Just like a circle, right? 360. So angles that meet up at a point add up to 360 degrees. Alright, so we talked about some angles. Okay, now we have to talk about vertical angles. So next we're going to talk about vertical angles. Let's say we have something like this, like an X again, right? And we're going to label these angles. Let's label this one A, B, C, and D, right? So we have A, B, C, and D. And vertical angles are angles that are right across from each other. So you see how A is across from C, and B is across from D. So angle A is equal to angle C, angle B is equal to angle D. So that's all vertical angles are, and this one vertical. Vertical, there we go. Vertical angles. Angles that are across from each other are equal to the same measurement. Okay. Can I erase the stuff on the left side here? Okay. Let's try an example together. Let's say we have. Make sure I'm trying this right. Okay. It's not perfect. This is a right angle. And now we're going to label it X, Y, Z. Okay. What we're trying to do is we're trying to find angle X, angle Y, plus angle Z. Okay, so let's start with what we know here. So we have angle X over here, we have angle Y over here, and then angle Z over here. Now, what's the first thing in this picture here that you guys see that you think can help us figure out what one of these angles is, measurement is?
I guess like you said before, with the vertical angles, where it's across of each other is equal to each other. So
Okay.
maybe the answer for Y is the same thing for the missing angle there.
Okay, very good, very good. You are on the right track. So angle Y here is equal to this one. Now this angle here is actually not missing. It's actually a right angle. Right?
Oh.
Yeah, the drawing's not very good, but this box here means that this is a right angle. And how many degrees is a right angle?
So that's 90.
90, right? So good. We know that Y is 90. So Y is 90 degrees. Good. So now we just got to find X and Z. So this is 90. This is 90. Well, how are we going to find X and Z?
That one is less than 89. So X and Z are less than 89 because it's an acute angle.
That's right. They're acute angles, so they have to be less than 89. Right? So that's good. Off to a good start.
So how do you find out? Like okay, it's less than 90, but like how
Okay,
less?
so you see how here we have like a straight line here, right? So we have a straight line here, and this equals 90, and we don't know what these two equal. Well, what does an angle, or what do angles equal together when they form a straight line?
180.
180, right? So X plus Z plus 90 has to equal 180, right? So what we could do is we could do 180 minus 90, which equals 90. And so X and Z together have to equal 90, right? So let's take 90 and divide it by 2, right? Very good, it's 45. And so we can say that X and Z both equal 45 degrees. Good, and so the question here was find X plus Y and plus Z, which is 180. So you could do it this way, finding the measure of each angle, and I would suggest you do because it's good practice, but also just by looking at the picture, right, it's a straight line, and whenever angles come together, form a straight line, they have to equal 180, right? So, good. That's about angles, I think. No, it's not. It kind of is. Now we have to talk about parallel lines. All right, I can erase this problem. Yeah. All right, so going along with our topic of angles, we need to talk a little bit about parallel lines. So we've heard this word parallel before. It basically just means lines that never intersect, lines that never cross, and they have the same slope as each other. So, for example, here, I just drew two parallel lines. These lines will never cross, they never intersect, and they have the same slope. And slope is just another word for the steepness of a line and the direction that it goes. Okay, so in geometry, when you take two parallel lines, I'm going to draw them this way now. When you draw two parallel lines and then another line going through it, you might have seen this. Now we have something called a transversal. Transversal. I think transversal refers to the line that's going through the parallel lines. And so when we have a transversal, well, we have a bunch of angles that formed, right? You got one here, 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 here. You have 8 angles, right, that just formed. And so the ones here, this one, this one, this one, and this one, these are called interior angles because they're the ones inside the transversal. So these 4 are called interior angles. And then the ones that are on the outside, right? The 4 on the outside, those are called corresponding angles because they correspond with the interior angles. Right, so like, the reason why it's called that, for example, if you take a look at this, this interior angle here, and then this corresponding angle here, together, they're going to equal 180 degrees, right? Because again, you have a straight line here, and you have 2 angles. Together, these 2 are going to be equal to 180 degrees. So, let's see. Yeah, let me label all these letters. So I have A. So we have angle A, B, C, D, E, F, G, and H. So here are the 4 properties of these angles that are formed by a transversal. So number 1, corresponding angles are always equal. Corresponding angles are equal. So for example here, angle A is equal to angle B, right? You see how they're both obtuse, right? So angle A is equal to angle E, and angle B is equal to angle F. Number 2, alternate interior angles are also equal. Alternate interior angles are equal. So for example, angle C is equal to angle F, and angle D is equal to angle E. So you see how all the angles on the inside, the ones that are across from each other, they're also equal. Property 3, same side interior angles are supplementary. And again, supplementary meaning they add up to 180 degrees. So we have C and E, right? Angle C and E, they're both interior and they're both on the same side, right? So that means that the measure of C and the measure of E, when you add them together, it's going to equal 180. Same thing with D and F, right? D plus F is going to equal 180 because they're same side interior. Lastly, all four acute angles are equal. As well as all four obtuse angles. Okay, so for example, angle G here, right? Angle G is acute because it's smaller than 90. Angle G is acute, angle F is acute, therefore they're equal. Same thing with B and C. B is acute, C is acute, they're equal. B, G, they're both acute, they're equal. Let's see, where else? C and, did I say C and F already? Anyway, you get the idea. And the same thing with the obtuse ones, right? H is obtuse, A is obtuse, they're gonna be equal. E is obtuse, D is obtuse, they're going to be equal. If you notice, right, you have angle G, right, which I said was acute, and then I said angle F was also acute. And if you look really carefully, they are also vertical angles, right? Vertical angles are angles that are across from each other, and those are equal too, right? Vertical angles are also the same measurement. So G and F are equal, and E and H are also equal. They're both obtuse, but they're also vertical, so that's why they equal one another. Okay, so let's try an example of these. So we'll leave this up for a sec. So you might see something like this, where you have M, N, and then somewhere off to the side is going to say something like this. You'll see M, two lines, and then N. And all this symbol means here is that M is parallel to N. That's what that little symbol means. Okay, and then we have, let's just call this on B. All right. Then we got angles A here, which is angle B here, angle C, and angle D. And what we have to do here is we need to find the sum of all the angles. So find A plus B plus C plus D. All right, so here is how we can do this. So A and B, right? A and B are both what? Are they acute or are they obtuse? Not acute, right? See how, yeah, they're obtuse, right? See how they're wider than a right angle, right? When an angle is wider than a right angle, it's obtuse. Good, so these are both obtuse angles. And then D and C are both acute, right? Because they're smaller than 90. And so, since we have two pairs, right? We have two pairs of one acute angle and one obtuse angle. Well, if we take one obtuse angle and we add it to an acute angle on a straight line, what does that equal? 180, right? Yeah, if we take, let's say, we take the obtuse here, so we take A, we add it to D, it's going to equal 180, right? Same thing with B and C, right? Let's say we have B, we add to C, that's going to add up to 180 as well. Because we have one acute, one obtuse on a straight line. So now we have two pairs of 180. We add them all together. We get a grand total of 360 degrees. Right? So, another way you can look at this is this angle A here, right, is also equal to this angle A here. Right? Because remember, all obtuse angles are equal. So A's measurement here is going to be the same as this obtuse angle over here. And then B's measurement over here is going to be the same as this one over here, because these are alternate interior angles over here, right? Because they're on the inside and they are on opposite ends. And so B's measurement will be the same over here. So when you add the four together, they all meet at this point. You get 360. Okay. I think that is, now that is it about angles. We're done with angles. Any questions so far? No? Okay, good. Good. Now we're going to start talking about polygons. Can I erase all this? No, yes? Okay. All right, so polygon is just a fancy word for a shape. So circles, triangles, squares, you name it. A polygon is a shape with a certain number of sides and a certain number of angles. So we're going to start with triangles. And with each polygon, we're basically going to be going over a few key features. Their interior angle measurement, perimeter, and area. But triangles are special because there's a lot of different things that geometry covers with triangles. So let's talk about triangles. Triangles are important because they have so many different features in geometry. So no matter what kind of triangle you have, the interior angles always add up to 180. 180 degrees. So like, for example, triangle here, there's three angles, right? You have 1, 2, 3. These three angles here, whatever their measurements are, they have to add up to 180 degrees. To find the perimeter of a triangle, you just add all the sides. You add the length of all the sides, I should say. So if I wanted to find the perimeter of this triangle, let's say this side was like 5, 7, and 9. I would just take 5 plus 7 plus 9, which is 21, I believe. Yeah, 21. So the perimeter of this triangle would be 21. And then the area of a triangle is just the base of a triangle times its height divided by 2. So let's say this triangle had a height being, let me start the base, go up. Let's say this triangle had a height of 4. So if I wanted to find the area of this triangle, all I would do is take the base, which is 9, times 4, the height, which is 36, divided by 2, and I would get 18. So the area of this triangle would be 18. Okay, oh yeah, and before I move on, let me just show you another kind of problem to see you might see it in the ASVAB. So with the interior angles of triangle, right? Sometimes they'll show you this, and they'll give you, let's say we have 50 degrees for this one, and 100 degrees for this one. And then what we would have to do is find the missing angle. So we have 100 plus 50, which is 150. And so we take 180 minus 150, that's going to give us 30. So our missing angle is 30. So that's another thing you gotta know how to do, is just find missing angles of a triangle. That's how you would do it. You add the ones you know, subtract that from 180, and you'll get your missing angle there. All right, so now I gotta talk about similar triangles. So similar triangles are, very similar in shape. They have the same shape, but they might have different sizes. So, like for example, here, right? They have the very same shape, but maybe this one has a length of 3, or width of 3, length of 6. And then 3 angles, so angle A, B, C. And maybe this one has 4, angle A, B, C. And then a side that's missing. And so a kind of problem that you might see on the ASVAB is, to find the missing side. So with similar triangles, their side lengths are actually proportionate, but proportional. So you guys remember we talked about proportions a few weeks back, right? So to find the missing side here, all you would do is set up a proportion. So this triangle, right, has a width of 3, length of 6. And we're going to set that equal to 4 over x, right? Because this side, 3, is proportional to this, right? And this side on the bottom is proportional to this one. And so we have this proportion here, we'll just cross multiply. So we get 3x equals 24, divided both sides by 3, x equals 8. And so this missing side here is 8. Right, so you see how they're completely different sizes, but the shape is the same, meaning that the sides will be proportional to one another. There are a few other kinds of triangles that you will see. So you have similar triangles. You also have isosceles triangles. This is the one I can never spell off the top of my head. Isosceles. So an isosceles triangle is a triangle that has 2 equal sides and 2 equal angles. So let's say it looks something like this, right? So this side and this side are equal to one another, which means this angle and this angle are going to be equal. Another example of an isosceles triangle might look like this, a little wider. Same thing, right? This side is the same, this side is the same, which means these angles are also going to be the same. So those are isosceles triangles. The 2 sides are the same. Oh, and these angles down here, right? These are called base angles, right? Because these are the 2 angles on the base of the triangle, right? So they're going to be equal to each other as well. Next up, we have equilateral triangles. Equilateral. An equilateral triangle is a triangle where the sides and the angles are all the same. So again, this is a human drawing. It's not going to be perfect. But let's pretend it is. And so all three sides are equal, which means that all three angles are equal. So based on what we know about triangles, what's the measure of one of the angles in an equilateral triangle? If all three angles are the same. This first question is how much, or what is the total measurement of the interior angles in a triangle? What do they add up to?
180.
They add up to 180, right?
Yeah.
So if all the angles in here add up to 180, and there's three of them, and they're all the same measurement, what's the measure of one of these angles? Not 90. So let's say we have 180 in total, right? That's the total. There are three angles that are all the same. So we're going to take this, we're going to divide it by 3. You have 60, right? So in an equilateral triangle, all three angles are 60 degrees. And then all three sides are going to be the same length, whatever that length might be. Okay, and lastly, we need to talk about right triangles. So a right triangle is a triangle with a right angle and two acute angles, right? So it looks something like this. So as you can see here, we have our L-shaped right angle right here, and then our two acute angles. And so the sides that are opposite of the acute angles are called legs. So these two sides are called the legs, and then this longer side across from the right angle is called the hypotenuse. Can I erase this similar triangles diagram? Okay. So now that we know this about right triangles and hypotenuses and stuff, there's something we need to go over real quick. You guys might have heard of it. It's called the Pythagorean theorem. So the Pythagorean theorem is this equation that someone came up with, where if you know the lengths, two of the lengths on the right triangle, you'll be able to find the third one. So typically, how a Pythagorean problem works is like you'll have the lengths of the legs, and you have to find the length of the hypotenuse, right? So usually, a right triangle is labeled like this. Let's say this side is A, this side is B, and the hypotenuse is C. And so the Pythagorean theorem is a very simple formula. A squared plus B squared equals C squared. Right? So here's a sample Pythagorean problem you might see in the ASCII. Let's say that leg A is 3, leg B is 4, find C. Right? So what we're going to do is we're going to take what we know, plug it into the Pythagorean theorem, and go from there. So A is 3, so we have 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, Now to cancel out a square, we need to take the square root, right? Square root looks kind of like this. Let me draw it. This is a square root symbol. Looks like that, right? We've seen that. So now we just have c, and the square root of 25 is 5. Because 5 times 5 is 25. So c equals 5. And that is how you would find a hypotenuse. That is Pythagorean theorem. Okay, that's it with triangles. Any questions on anything about triangles or just geometry in general? Anything we've gone over so far? No? Okay, great. Let's move on to quadrilaterals. All right. Quadrilateral. So quadrilateral is a very broad term for a polygon with 4 sides. 4 sides and 4 angles. And with any quadrilateral, you would find the perimeter of them the same way you would find the perimeter of a triangle. Just add all the sides, right? But in this lesson, I think I'll be able to show you guys a few shortcuts in case they don't give you like all of the side lengths. There are still ways you can find perimeter of quadrilaterals even when you don't know all of the side lengths. So let's start with a parallelogram. Parallelogram is a quadrilateral that has 2 sets of parallel sides. So we have a parallel side, let's say going this way, parallel side going this way. So they look something like this. And the opposite sides are equal to each other. So this side is going to equal this side, and then this side is going to be equal to this side. Right? And so to find the area of a parallelogram, it's just base times height. Base times height. So let's say that this one has a base of 4, height of 2. 4 times 2 is 8. So the area of this parallelogram would just be 8. Now, as for the perimeter, let's just say that, I don't know, this side is 3. So if we wanted to find the perimeter of this parallelogram, we don't have all the sides we can have, right? All we have is a 4 and a 3. Well, this side is equal to this one, right? So we know that this is also going to be 4 over here. This is 3, so this side's also going to be 3. Now we have all the sides, just add them all together to get the perimeter. So 3 plus 3 is 6, plus 4 is 10, plus 4 is 14. So this one would have a perimeter of 14. So that is a parallelogram. Next we need to talk about rectangles.